Hello, everyone. So we have another nice logarithm problems. Okay, so we are given an equation in terms of log, right? And then we like to find the number of ordered pairs A and B. Both will be integer, and then we have some restrictions right here. Okay, so when you look at the equation we are given, so this is log like base A of B, and the other one is log base B of A. So they're just like a swap, right? So if you see the immediate, I will ask you to remember this property. So when you take the log base A of B times the log base B of A, the product of these two is equal to 1. And if you don't know why this is the case, I will, I guess, ask you to review somehow, because this is one of the great features of the logs that needs to be remembered. So that's the one of the feature. Okay. So, but at the same time, so I don't want to like just replace this guy with the reciprocal of the other guy, because if you divide both side by one of these, you will get one is other one over the other, right? So, which is why I will make a substitution. So if I choose the log maybe base A of B equals X, then the other guy, the log B base B of A has to be 1 over X, okay? So, and I'm gonna plug it right here. So the first one was X, right? And then you got 6 times 1 over X. So that should be 5. So this is a quadratic, I guess, because if you multiply both sides by X, you will get X squared, and then plus 6 equals 5x. If you pull everything one side, so x squared minus 5x plus 6 is 0. So it's factorable. So x minus 2 and x minus 3 has to be 0. So I feel like we are all good with these parts. So it's just AIME problem. So we should be good with that. And then this is 2 and this is 3, right? So we have these two solutions. What are those x's? X is just basically this log, right? So let me replace with those. So if you replace x with 2, so that means the log base A of B has to be 2. Meaning of this, A to the second power, because I don't like dealing with the logs. It's better in exponential form. So that will give us B equals A squared. And if I plug 3 for x, that will be A to the third will be B. So you will get another equation, B as A to the third power. Okay, this is good so far, but let's use these two to get what we want. So the question was number of pairs A, B as integers, and then A has to be at least 2 all the way to the 2000, like 5, and then B is also the same thing. So we know A is square to get B or cube to get B. So which means maybe it's better to think about what are the perfect squares or perfect cubes that is not going to be larger than the 2005. So that is good one to start with, like plugging some values. But I will, if you do like 50, so 50 square is just 2500, which is larger than that. And that is why 50 cannot be the answer for the square. So if you do 40, that's 1600, that's smaller. But if you experience the squares, I guess 45 is kind of closer to what we want. But if you do square 44, so let me just write this, 44 square is actually 1936, which is smaller than 2005. But if you do 45 square, this is one of the common numbers that we see, is 2025. Since this is larger than 2005, we cannot go with 45. So that means the B can be at most 1936, which is 44 squared. So I can choose, like I can choose A's, 2, like 3, 4, 5, anything all the way to the 44. So if I choose A is 2, that means B will be A squared. So I can just write the corresponding B's if I really want it. So if I choose 2, that will be 2 squared will be 4, 3 squared will be 9, that will be 16. It will continue, and then the last one will be 44 squared, so which is 1936. So which is all possible. So we could have any numbers for a's 2 through 44, and for those a's we have the corresponding b's, so which is my pairs basically as integer. And since we have 2 through 44, so we don't have one, so out of 44 numbers, so that will make us 43 pairs. So this is something. And the second case is something similar, because we said b has to be a square. If that's the case, so I can choose those a's and b's. If I choose a as like 2, and then b will be cube of this, which is a. If I choose 3, that will be 27. It will continue until some point. I just need to know when to stop. And to do so, I'm going to use a similar reasoning. If you take the sum cubes, like 12 to the third power is 1728, which is like smaller than this. And if you try 13 cube, I guess that is larger than 2005, which is 2197. So if you don't remember those immediately, you can just test a few numbers. We start with 10 maybe. And the largest I can go with is 12, right? So that will be 12. And the corresponding b will be 12 to the third power. Since we have any integer in between 2 to 12 for a, and the corresponding values will be b's, so that will be the number of pairs. So 2 through 12 will give us 11 pairs. So we have 11 pairs right here, 43 right here. If you add them, you got 54 pairs as the final answer. But in this problem like this, you want to be extra careful, because if you miss one of those numbers, the answer will be different. So I guess that is a good reminder. Okay. Yeah, that was the answer. I'll see you in the next video.